For better or worse, we live in a world profoundly affected by Sigmund Freud. If I had to ask you, name a famous psychologist, the answer, most of you, would be Freud. He's the most famous psychologist ever, and he's had a profound influence on the 20th and 21st century. Some biographical information: he was born in the 1850s. He spent most of his life in Vienna, Austria, but he died in London, and he escaped to London soon after retreating there at the beginning of World War II, as the Nazis began to occupy where he lived. He's one of the most famous scholars ever, but he's not known for any single discovery. Instead, he's known for the development of an encompassing theory of mind, one that he developed over the span of many decades. He was, in his time, extremely well-known, a celebrity, recognized on the street. And throughout his life, he was a man of extraordinary energy and productivity, in part because he was a very serious cocaine addict, but also just in general, he was just a high-energy sort of person.
The lecture is about history of psychology. The speakers talk about profoundly affected by famous psychologists and biographical information. He also pointed out World War II and famous scholar and single discovery with encompassing theory of mind. In the end, the lecture explained how span of many decades and extraordinary energies affect cocaine addicts. I think that's enough. Thank you so much.
We can ask two fundamental questions about animal behaviour. They're referred to as proximate and ultimate. Proximate questions are those concerned with the mechanisms that bring about behaviour. Ultimate questions are those concerned with the evolution of behaviour. We can divide the proximate and ultimate questions into two sub-questions. For proximate, how does the behaviour develop? And secondly, what causes the behaviour? For ultimate, we can ask, how did the behaviour evolve? And secondly, what is the adaptive significance of the behaviour? What's its purpose? Together, these comprise what are called Tinbergen's 4 questions about animal behaviour. Nico Tinbergen was one of the founding fathers of the study of animal behaviour. These questions represent the different ways of studying animal behaviour. And understanding the difference between those 4 questions are fundamental to understanding behaviour and indeed the whole of biology. How do we study animal behaviour? Well, that depends on the type of question we're hoping to answer.
The lecture is about animal behavior with fundamental questions. The speaker talked about animal behavior with proximate and ultimate questions. He also pointed out behavior, evolution of behavior, and adaptive significance. In the end, the lecture explained how founding fathers of animal behavior and study animal behaviors affect the sub-questions and the whole of biology. I think that's enough. Thank you so much.
Sometimes it's the little things that can make big things happen. Fleas and the plague, atoms and nuclear bombs, diminutive leaders in world history. Soot is one of these little things. Soot, also known as black carbon, is released when you burn dung, coal, diesel fuel, and wood. From LA to Mumbai, soot causes respiratory illnesses like lung cancer and asthma, and contributes to 1.6 million premature deaths every year, mostly among the poor. And it gets worse. Atmospheric currents carry soot thousands of miles from where it is produced to the Himalayas and the Arctic. Black carbon, being black, absorbs sunlight, so even a little soot on snow makes it melt faster. And when snow melts, global sea levels rise, threatening our freshwater, indigenous communities, and polar bears who hunt on the Arctic ice. Climate change has been a big thing for a while, and carbon dioxide has been its main cause. Scientists estimate that soot causes 25% of human-caused global warming. It's the second leading cause of Arctic warming after carbon dioxide. Let's not underestimate the impact of this tiny particle. But there's good news. Reducing black carbon may be the fastest way to slow global warming and buy time for the Arctic. Yes, even more so than changing a light bulb. And since black carbon only stays in the atmosphere for a couple of weeks, reducing it would produce results immediately. Of course, reducing soot alone won't solve global warming, but solving our soot problem now will help buy time for the Arctic and allow us to deal with the bigger problem of carbon dioxide. We have the cleaner industries, cook stoves, and diesel. Now we have to use them. In developed nations, we've significantly reduced our black carbon, but we still have much more to do. We need to tighten our standards at home and invest in cleaner technologies in developing nations. In a world going on 7 billion people, you might feel rather little yourself. But if you urge the US government and the European Union to take the lead on black carbon reduction, you can make a big difference. Go to stopsoot.org and help stop these little things from causing big trouble.
The lecture is about human-caused global warming. The speakers talk about black carbon and atmospheric currents. He also points out global sea level, freshwater indigenous communities, and polar bear in different climate change. In the end, the lecture explains how carbon dioxide and black carbon reductions affect cleaner technologies. I think that's enough. Thank you so much.
I think with our linguistic training, we are also get all this invisible training to be authorities, to be the people who know. It is part of that process that you come out as a world authority on your chosen subject. But when we move into working with communities, we have to recognize that communities have to be the authority in their language. Actually, a woman in the class I'm teaching at Sydney at the moment, a career woman, expressed this very nicely. Although she was talking about something else, she was distinguishing expertise from authority. And certain linguists, because of our training, we have expertise in certain very narrow areas of language, but we don't have the authority over what to do with that knowledge or what to do with our knowledge that the community produces. I guess for me, the bottom line is languages are lost because of the dominance of one people over another. That's not rocket science. That's not hard to work out. But then what that means is in working with language revival, we continue to hold the authority. We actually haven't done anything towards undoing how languages are lost in the first place. So in a sense, the languages are still lost if the authority is still lost.
The lecture is about linguistics training. The speaker talks about invisible training and word authority. He also points out chosen subjects and career women and expertise from authority and narrow areas of language. In the end, the lecture explained how the bottom line and language revival affect rocket science. I think that's enough. Thank you so much.
Why is it difficult to make a robot like a human being? Why can't robots finish the work easily like human beings? For some tasks, it is easy and simple for humans to complete, but it is very difficult to ask a robot to do what we want because humans and robots have different recognition functions. For example, considering the insights, it is hard for robots to recognize colors because they do not have sensory mechanisms. Artificial intelligence scientists have to devise a sensor that is implanted to robots to enable them to recognize different colors. The sensor has a camera on it to capture pixels, and then will translate the pixels into an image, which is not as easy as expected. This process is very complex. The translation of every pixel to accurate things could be difficult, especially color differentiation, which needs complicated sensors to fulfill. So the improvement of the sensor is necessary. In conclusion, there is no comparison between humans and robots.
The lecture is about robotics recognition function and sensor. The speaker talks about human being and recognition functions. He also points out sensory mechanisms, artificial intelligence scientists, and defines a sensor. In the end, the lecture explains how translates pixel into an image and color differentiations affect complicated sensors. I think that's enough. Thank you so much.